Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today our topic of discussion is UMTS WCDMA. The points that we cover today are why new radio access systems required, frequency allocations in UMTS, WCDMA for UMTS, UMTS architecture, UMTS radio interface protocol architecture. Now the question arises that why we need new radio access systems. As per the requirement of today's emerging era, just voice communication is not enough. So to make better use of communication scenarios, we launch UMTS. UMTS stands for Universal Mobile Telecommunication. UMTS does not only support voice communication but also gives us the access to the packet data services, IP data in the core network and wireless IP. Now new services in mobile multimedia need faster data transmission and flexible utilization of the spectrum, as our previous techniques do not provide the faster data communication, and also the spectrum utilization is an issue. For example, FDMA frequency division multiple access and TDMA time division multiple access have the following limitations. TDMA wastes time resources, whereas FDMA wastes frequency resources. That's why to overcome these limitations, we are using CDMA instead of these techniques. CDMA provides us the whole bandwidth constantly and continuously. Now the new version of CDMA is wideband CDMA, that is also called WCDMA, that is selected for the radio access system for UMTS in 1997. WCDMA not only support the voice communication but also carry the data at high rates, for example TV video streaming and the interactive sessions data requirements. Now the frequency plans are frequency allocations for UMTS. Frequency plans of Europe, Japan and Korea are same or harmonized, but the US plan is incompatible. The spectrum reserved for 3G elsewhere is currently used for the US 2G standards. So overall in all countries, that the standard for the channel access method used as IMT 2000 band in Europe, FDD to multiply by 60 MHz. Now Americans are using the frequency plan Edge, WCDMA and CDMA 2K in the existing bands that are already used by 2G systems. But Europe IMT 2000 band, WCDMA, GSM 900/800 band, Edge. Japan is also using IMT 2000 band, WCDMA. Korea is also using IMT 2000 band, WCDMA, and the rest of Asia is also following the same. But in Brazil and other Latin countries, European spectrum IMT 2000 band, WCDMA, GSM 1800 band, Edge are used. Now we will switch to the UMTS IMT 2000 architecture. UMTS uses the same core networks as that of the GPRS and uses entirely new radio interface. New radio network in UMTS is UTRON, that is UMTS Terrestrial Radio Access Network, and is connected to the core network by ILU interface. Now the mobile terminal in UMTS is UE, that is user equipment. UE is connected to node B over high speeds using the interface, that is UU. Node B is equivalent to the BTS and GSM and typically serve a cell site. Several node Bs are connected by a single RNC. RNC is connected to the core network further. One of the new interface in UTRON is LUR, which connect to RNCs. Now, in UE, USIM contains the authentication information and also the associated algorithm encryption and subscriber related information. In UE, ME is user independent. As I already told you that RNC is same as that of the BTS and GSM. Its functions include handover, channel management, baseband conversion, channel encoding and decoding, interfacing to other network elements. Now, the working of radio network controller is as follows. While connecting to the UE, RNC provide firstly the connection to UE, then the drift RNC lends resources of serving RNC for a particular UE. Each RNC also has the controlling RNC role towards its node Bs. Pictorially, it is shown here. Now, the network architecture of UMTS is covered. Now, we will further discuss that what are the service classes in UMTS. Service classes means the services that UMTS is providing. In 3G network, ME will be able to establish multiple connections simultaneously. There is no restriction on the connections. Now, network should be efficient that it can handle all the connections simultaneously. That's why the quality requirements that is required have following two parameters. First parameter is granted and maximum bitrate possibilities, and second is the permissible delay. Because we are discussing that UMTS is better than previous technologies that are used in cases of data rates and low delays. So, based on the quality of service criteria, multimedia services has been further classified. First of all, conversational services and the conversational quality of service. The most delay sensitive and applications video telephony or voice over IP. Next is the streaming flow, which is steadily and continuously required. It is server to user. Third quality of service requirements are in interactive sessions, web browsing for example. A user may request timetables of buses, trains or flight schedules. So in these cases, better data rates and low delays are required. Now, the previous services that are already provided by the previous technologies are short messages, file transfer, email. That is also highly handled in UMTS in terms of quality of service, in terms of delays and high data rates. Now we will switch to the radio interface protocol architecture. UMTS using layered protocol architecture at different interface point, each layer performing a set of specific functions. The number of rows that are in UMTS are L1 physical layer, L2 medium access control layer, L2 is again radio link control layer, and L3 is radio resource control layer. Now the radio interface protocol is divided into the two plan. First is the control plan and second is the user plan. Control plan is concerned with the signaling and control required to establish the connection between a UE and network, or request specific services or request from the networks. Whereas the user plan specify how the user data is to be transferred across an interface after connection has been established. Now now we will discuss how the layers are working in these two planes. First, layer 1. Layer 1, the actual medium of transfer, that is physical layer. The main function of this layer include RF processing, modulation, demodulation, multiplexing, demultiplexing of physical channel. Error detection and correction are also handled here, and rate matching, power control and synchronizations. Now the second layer has the two sublayers, that are MAC layer and RLC. MAC layer responsibilities are mapping logical channels to the transport channel, an interface between L1 and L3, and packet multiplexing and demultiplexing. Also, the measurement related to traffic volume on the logical channel and reporting to L3 is handled by MAC layer. Now, the sublayer of layer 2 is RLC, radio link layer, segmentation, reassembling of variable size data packets. Also, the error correction is handled here, controlling rate flow, concatenation, ciphering and preservation of higher order PDU. Operates in three modes as in GPRS. Now the third layer of UMT interface protocol architecture is RRC, contains sublayers, but RRC is one that interact with layer 2. It handles control plane only, signaling between the UE and network or the core network, responsible for barrier functions like establishment, release, maintenance and reconfiguration in the user plane, and of radio resources in control plane. Functions of the RRC include radio resource management and mobility management, as well as the power control, routing and paging. Two other layers that are also included in UMTS are Packet Data Convergence Protocol and Broadcast Multicast Control. Major functions being compressed of PDU at transmission and decompression at receiving end in all of the three modes of RLC, that is handled by Packet Data Convergence Protocol. Now the broadcast and the multicast control is handled by BMC, functions only in transparent and unacknowledged modes, providing broadcast, multicast scheduling and transmission of user data. Dear students, this is the last topic that we are discussing in the UMTS. Hope you have the better understanding of now the UMTS architecture and the layer architecture that is followed by UMTS to handle the communication. Thank you. Allah Hafiz. Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Today our topic of discussion is UMTS WCDMA. The points that we discuss about UMTS today are: why new radio access system requires frequency allocation in UMTS, WCDMA for UMTS, UMTS architecture, UMTS radio interface protocol architecture. Now the question is why we need a new radio access system. As per requirement of today emerging era, just voice communication is not enough. So to make better use of communication scenarios, we started UMTS. UMTS stands for Universal Mobile Telecommunication System. UMTS just not only support voice communication but also the packet data services, IP data in core network and wireless IP. Now new services in mobile multimedia need faster data transmission and flexible utilization of the spectrum. But our previous technologies do not provide the faster data communication, and also the use of the spectrum is also less. For example, frequency division multiple access and time division multiple access have the following limitations: TDMA waste time resources and FDMA waste frequency resources. That's why to overcome these limitations we are starting UMTS with CDMA. CDMA stands for Code Vision Multiple Access. CDMA provides us the whole bandwidth constantly and continuously. A new version of CDMA is WCDMA Wideband Code Vision Multiple Access that is used for UMTS in 1997. WCDMA just not only support the voice communication but also carry the data at high rates, for example TV video streaming and interactive sessions. Now the frequency allocations for UMTS in Europe, Japan and Korea, frequency plans are same, but US is incompatible to the other areas. The standards that US is using as 2G are used as 3G in other countries. Now the overall standard that is used for UMTS is IMT 2000 band in Europe, but Americans Edge, WCDMA and CDMA 2K in the existing bands is using, whereas Europe is using IMT 2000 band, WCDMA, GSM 900, 1800 band, Edge. Whereas Japan is also using IMT 2000 band WCDMA, Korea is also using IMT 2000 band WCDMA. The rest of Asia is also following the same. But in Brazil and Latin and other Latin countries, European spectrum IMT 2000 band WCDMA, GSM 1800 band Edge is used. Further, now we will discuss UMTS IMT 2000 architecture. UMTS uses the same core network as that of the GPRS and uses entirely new radio interface. Three parts of the UMTS architecture are UE user equipment, UTRAN, that is UMTS terrestrial radio access network, and the core network. New radio network in UMTS UTRAN is connected to core network via LU interface, where UE is connected to UTRAN via UU interface. Mobile terminal in UMTS is UE. U is connected to node B over high data rates through the interface UU. Node B is same as that of the BTS in GSM and typically serve a call setup. Several node Bs are connected to RNC via sync. RNC are connected to the core network. One of the new interface that is included in UTRAN is LUR, which connect to RNCs. Now detailedly we discuss each part. Firstly, USIM contains authentication information and associated algorithm encryption and subscriber related information. In UE, second part is ME, that is user independent. Then we will switch to the node B and RNC. Node B is same as that of the BS in GSM. Its function include handover channel management, baseband conversion, channel encoding and decoding, interfacing to the other network elements. Now the function of RNC concerning one connection between UTRAN and one UE, the following roles of RNC are: first, serving RNC that controls the connection to a UE, drift RNC that lends the resources of serving RNC for a particular UE. Each RNC also has the controlling RNC role towards its node B. Following is the pictorial representation of an RNC functionality. Now, after discussing the architecture, we will discuss the service classes in UMTS. As we are discussing that UMTS providing the high data rates and better connection management. So the two parameters that are required for the quality management are guaranteed and maximum bitrate, possible kbps, and permissible delay. This should be granted that maximum data rates are achieved and low delays as compared to the previous techniques. So based on the quality service criteria, multimedia services has been further classified. Firstly, conversational services, the most delay sensitive because applications like video telephony and voice over IP require less delays and high data rates. Then we will discuss streaming flow, which is steady and continuous. It is server to user. Next, applications where the quality of service is required are the interactive sessions, for example web browsing. Also, a user may request timetables of buses, trains, or flight schedules. So this should be with the less delay and accurate and with the faster data rates. The other services that are already provided by the previous techniques are short messages, file transfer, email. These are also managed in UMTS with high data rates and less delays. Now we will discuss that how UMTS is working. UMTS working protocols are actually the layered protocol. This is providing the layering at different interfaces, each layer performing a set of specific functions. The layers that UMTS using are physical layer, medium access control layer, radio link control layer, and radio resource control layer. Now actually the layered architecture is further divided to two plane. First plane is control plane and second is user plane. Control plan concerned with the signaling and control required to establish the connection between a UE and network, or request specific services or request from the network are handled in control plane. Whereas the user plan specify how the user data is to be transferred across an interface after connection has been established. Now how the layers are working in these two planes are: first of all, the layer is the physical layer. Physical layer is actually transferring the data. The main function of this layer include RF processing, modulation, demodulation, multiplexing, demultiplexing of physical channels only. Error detection, correction, read matching is also handled here. Next is the layer 2. Layer 2 actually comprises on two main sublayers. First one is the RLC, radio link control layer, and medium access control layer, MAC. Now medium access control layer is responsible for mapping logical channels to the transport channels and interface between L1 and L3 and provide packet multiplexing and demultiplexing. Measurement related to traffic volume on logical channels and reporting to the layer 3 is also handled by MAC layer. Now RLC is responsible for segmentation, reassembling of variable size data packets, error correction by transmission and acknowledge data transfer mode, controlling rate flow, concatenation, ciphering, and preservation of higher order PDUs. It operates actually in three modes as in GPRS. The third layer, that is RRC, contains sublayers, but RRC is the one that interact with layer 2. It handles control plane, signaling between UE and network in the connected mode, responsible for the barrier functions like establishment, release, maintenance, and reconfiguration in the user plane, and of the radio resources in control plane. Functions of the RRC include radio resource management and mobility management, as well as power control, routing, and paging. These are the three layers using this UMTS work, and each layer is independent of the other layer, so changes in one layer will not affect the functionality of the other layers. But with these three layers,